Well, hello, pre-calculus students, calculus students, and especially general seekers of truth. We continue our work with limits of composite functions now by looking at a numerical approach. Now, we will confirm the results here by graphing, but I think it helps people a little bit more to understand this from a numerical as well as a graphical and algebraic approach. All right, so we have f of x and g of x, and we have this limit here. So when I say numerical approach, what we're going to do is we're going to look at f of x only as x approaches 1 from the negative direction. Okay, and let's see what that looks like exactly. So now let's see. I'll make a little table here, and we'll say x and f of x, and we want to approach 1 from the negative direction. So when we say 1 from the negative here, this is another way of saying that we are increasing towards 1. Okay, we are increasing toward 1 without actually getting to 1. So we'll start with a number that maybe is close to 1, 0.9, and then perhaps 0.99, and then 0.999. And I'm just going to take these numbers and plug it into this function right here, and let's see what we get. Alright, so when I plug in 0.9 into f of x, I get negative 1.9. Negative 1.8. When I plug in 0.99, I get negative 1.98. And then when I plug in 0.999, I get negative 1.998. And so let's see exactly what this means. Well, you can see here that, well, let's look over here on this side. Again, x is approaching 1 from the negative side. In other words, all these numbers here that we're trying, they are increasing towards 1. And these numbers here, you can see that they are getting closer and closer to 2, right? So f of x is getting closer and closer to 2. But the issue is, from which direction? Well, you can see here that these numbers here, they are, negative 2. I want to be very, very clear here. All of these numbers here are getting closer and closer to negative 2, but from the positive direction. In other words, we're going down, we're decreasing towards negative 2. Right? We're getting closer and closer to negative 2, but from the positive direction. So let's just see a little bit what I mean here. So let's say negative 2 is like right here. Okay, and then that would mean that negative 1. Let me draw a slightly better graph here. So like negative 2 would be like right here, and like negative 1.998 is like here, and then negative 1.98 is here, and then negative 1.8. So you see, as x gets closer and closer to 1 from the negative direction, f of x is getting closer to negative 2 from the positive direction. It's going from the right to the left on the number line here. On the graph, what you'll see, it's going from top to bottom. But we can say that it's decreasing towards negative 2. Okay, so let's be clear. As you're approaching negative 2 from positive direction, that means we are decreasing toward negative 2. So now we can alter this limit. We can say that this is really the limit as x approaches negative 2 from the positive direction of g of x. And so now we can make our table as well, x, and we want to approach negative 2 from the positive direction. So negative 1.8, negative 1.98, negative 1.998. And let's see what's happening here with g of x. So now once we do this, we get that the answer here, this is approaching 1, and so is this, and so is this, and you're going to get these are all exactly 1. So our final answer is equal to 1. Okay. So this limit of this composite function turns out to be exactly 1. Now let me continue here, and I'm going to paste a couple of graphs in here just so that we could see exactly what is going on and how do we relate it to what's going on numerically. Alright, so with the help of Desmos, my graphing tool, I've graphed that this is f of x, right? And then this graph over here is the graph of g of x. Right? And it actually looks like this, and there's this thing going on here. Just to be clear, it's a graph with a jump discontinuity, and really there's like a hole here, and there's a hole here, and then there's also a hole right here and a hole right here. And the reason for that is because when you put in 1 into f, it's going to be undefined. And when you put in -2 into g, you're also going to be undefined. But this is the graph that we get. And now let's see exactly what's going on here. So as x approaches 1 from the negative side, in other words, going towards 1, you see here that f of x is going down from above, from the positive side, down to -2. So it's down to -2. And so we need to apply that exact same limit process with g of x now. So as g approaches -2 from the positive side, as x approaches -2 from the positive side, g is approaching 1. It's staying constant at 1. So 1 here is our final answer. Okay, so hopefully this process here, this exercise that we just did, helps to clarify a few things for you. As what we say when we mean from the positive side, it's not necessarily from the right, because when we talk about the output or the range, we could be talking about coming from above versus coming from below. So you should stick with the terminology coming from the positive side, coming from the negative side, or we can say increasing toward or decreasing toward. Okay, either of those will also work just fine. So there you have it. That's the end of this section here. Make sure you watch the next video where we talk about just some more examples that may be a little bit tricky. All of these problems are a little bit tricky, but keep struggling the good fight, and ask for help as always if you need it. Thank you for watching, and have a wonderful day.